Okay, getting off to a start. The first thing you want to look at concerning motion is what your eyes are telling you. Now, as you recall the statement, seeing is believing, and believing is only something you practice if you're at a distance from the truth, and thus you're located in the zone of less than truth. And so what your eyes tell you concerning motion is incomplete. So if seeing is just believing rather than connecting you directly to the truth, it would be logical to make your mind more intelligent than your eye. So in other words, you don't just accept what your eye tells you, you raise your intelligence to a higher level than an eyeball. So anyways, concerning motion, the eye basically tells you that it contains two variables, this concept known as motion. Motion across a certain distance, be it short or long, and motion at different speeds, slow, fast, any particular speed. And what you want to do now that you've now acquired that information based upon what your eyes are telling you is either just leave it like it is by being stupid, or expand this awareness to the point of infinite, so you get a better picture of what it is you may have accepted, through the act of seeing is believing. Anyways, the first thing we notice is that, again, we have variables, distance and speed, right? Two variables. So variables range from 0 to infinity. So again, you want to push these to infinity so you can understand what it is you're looking at. So that means you want to travel across an infinite distance, but at an infinite speed. Now, traveling an infinite distance, what does that mean? Or across an infinite distance, I should say. It means you will just keep on going forever, crossing that infinite distance, because there's no end to it. If it was a finite distance, you could eventually cross that finite distance and complete it, the trip. But if it's an infinite distance, like I say, you just keep on going forever. So in that case, you would go on forever. Next, what about infinite speed? What is an infinite speed? Kind of difficult to think of it because the human mind is limited to a finite capacity, a finite size. So trying to put an infinity within a finite is a little bit tricky when it's the finite that's doing the work, the thinking. So what you could do is use the process of elimination. First define finite speed. Let's say we're going to move from point A over to point B. And let's say in this case it takes us 10 minutes to complete the trip. That means we're definitely traveling at a finite speed because we could speed up and complete it in less than 10 minutes, let's say 5 minutes. But that would mean we're also traveling at a finite speed because we could always speed up and complete the trip in less than 5 minutes. Or we could reduce it down to 1 second. But that means we could still speed up and complete the distance in less than 1 second. Thus, if a time period is required to get from point A to point B, then obviously you're traveling at a finite speed. However, using the process of elimination, if you go from point A to point B and complete that trip in 0 time, obviously you're traveling at an infinite speed because you can't go faster than that. Any time period, no matter how small, there can always be a smaller time period, right? So that would be finite. But 0 time, that's your infinite speed. So in that case, no matter what distance you move across space, you would cross that distance in no time at all. So there we basically have the two pieces of information, and so you put them together, as you're traveling across your infinite distance at an infinite speed. It simply means that you will go on forever in no time at all. So that means you'll go on forever, which means it'll never finish, but it'll all be over within no time at all because you're traveling at an infinite speed. So it'll never finish, but it'll all be over within no time at all. So obviously the point being is that what your eyes were telling you concerning motion, across a certain distance, certain speeds and so forth, was misleading. But if you didn't bother expanding it to the point of infinity, in other words, you chose to be stupid, then you wouldn't have seen that it leads to somewhat of a paradox. So anyways, you begin to think, what's really going on? Because you can't have a forever time period and a zero time period both being components of a single function. You can't have two opposite extremes being part of a single function, a single event. It's just not possible. So holistically, it's impossible. So the next best thing you think of, therefore, is relativistically. So let's say from one point of view, let's imagine this is a clock. This clock is ticking. But from another point of view, time is at a standstill. Clocks aren't ticking at all. So if you're traveling at infinite speed, whatever distance you cover across space, you complete it in zero time. So you could be whipping across space, but not across time. But elsewhere, time is still ticking. So time could go on elsewhere forever, while time is at a standstill for you. So you can go on forever in no time at all from your point of view. In fact, you don't really have a point of view because you're just frozen in time. So you wonder, well, how can you do this? So what you do next is you step back and see what information you've acquired so far. Okay, so now we'll start bringing some geometry into the picture here, and we'll start making note of specific dimensions. We'll start off here with space. Going in this direction. I can represent infinite depth or infinite speed across space. Okay, now we'll introduce the dimension of time in this direction. And again, that could represent an infinite depth or infinite speed across time, dimension of time, or both. You can stack them. Okay, so the first thing we notice is if we're going in this direction, right, across space, but not across time, that's one extreme. The maximum speed you can go across space, but not across time, because whatever distance you cover, you complete it in zero time. Therefore, you're moving across space, but not across time. But if you go to the opposite extreme concerning motion, meaning being at rest in space, no motion at all, let's say you stay right here, are you at complete rest? And the answer is no, because now you're moving through time. So you begin to realize it's a game of give and take. You can be moving across time, but not across space. But if you start to move across space, you start losing out on motion across time until eventually you get to this direction where you're moving across space only. So it's a game of give and take. One, the other, or a mix of the two. But what you can't have is this maximum and this maximum at the same time, which means they're both encapsulated within a finite, which means that if you move across space, you're going to be moving at some finite velocity. Or if you go in this direction, you'll be moving across time at some finite velocity or magnitude of motion. Or in any other direction you travel, you'll also be confined to that finite magnitude of motion. So I'll mark that as well. So no matter which direction you go, you're going to be confined to that finite magnitude of motion. But what's interesting is, if you're going this way, you're moving across space. You're not moving across time, but you're moving. In this case, across space. If you go in this direction, you're not moving across space, but you're still moving. You're moving across the dimension of time. Or if you go in any other direction, you're still moving. And so nowhere in here can you stop moving. You're always moving at a fixed magnitude of motion. All you can do is change the direction of that constant motion. And so that can help you understand something like, for instance, an astronaut out in space, an American astronaut, and of course, floating in space, right? And being an American astronaut, no doubt he has a baseball with him, right? And so there he is floating with the baseball. And they're both going in the same direction, whatever direction that is. But if he gives the baseball a push, it just keeps on going, which seems kind of strange, but shouldn't be, because it's always been going. It doesn't just keep on going. It's always been going. All you've done is changed its direction of constant motion. You've added speed across space and subtracted from motion across time. So you just simply changed its direction of travel. Okay, so next we'll put an object on here, and basically I'll call it my spaceship. And to make this geometry easy to work with, I'll make the length of my spaceship the exact same length as this constant motion vector. And I'll start out with the object being at rest in space and therefore moving across the dimension of time. Okay, so there it is, extending across space and moving across the dimension of time.